Picture a function that just received bad input. Right now, the program has a choice. It can stop everything and complain loudly right where the problem was found, or it can try to be helpful, patch over the gap with a default value and keep running. Most of us were taught that crashing is bad and uptime is good, so the second option feels like the responsible one. But there's a school of thought in software design that says the opposite is usually true. It's called fail fast, and it's one of the most quietly influential ideas in how reliable systems get built. It shows up in assertions, type systems, API validation, circuit breakers, and in nearly every post-mortem where the real bug was 3 files away from where it actually broke. Today we're breaking down what fail fast actually means, how it works mechanically when it's the right call, and just as importantly when it absolutely isn't. So here's the actual dilemma. A function gets a value it didn't expect, maybe a null, maybe an empty string, maybe a number outside a valid range. Do you crash immediately or try to limp along? Limping along usually looks like this. A null becomes a 0 becomes some default. The bad value keeps moving downstream quietly through 3 or 4 more function calls, each one assuming the data is fine because nothing complained yet. Eventually something breaks, but by then you're nowhere near the actual cause. Fail fast takes the opposite approach. The moment that bad value is detected, the program throws an error right there with the exact value and the exact call site still sitting in scope. Here's the thing worth sitting with. Both paths lead to a crash eventually in almost every real case. The only real question is where that crash happens and how much context you still have left once it does. Let's make this precise because fail fast gets confused with other ideas constantly. The actual definition is this. A system reports any condition that's likely to indicate a failure as soon as that condition is detected, instead of operating on assumptions it can no longer guarantee. That's different from failsafe, which tries to degrade gracefully, pick a sensible default, log a warning, and keep serving the user. It's also different from silent failure, which is what happens when nobody checks at all, and bad state spreads invisibly until something far away breaks for no obvious reason. Fail fast is loud and specific and early. Fail safe is graceful but can hide real problems behind a comfortable default. Silent failure is the one to avoid at all costs since it gives 0 signal until the damage is done. None of these is universally correct. Fail fast is a deliberate trade, accepting more crashing now for fewer mysterious failures down the line. Mechanically, fail fast is simpler than people expect. Picture untrusted input arriving at some boundary in your system, maybe a function argument, maybe an API request body. Right at that boundary, you run a precondition check. If the check fails, you throw or assert immediately with the bad value still attached to the error. If the check passes, the function proceeds normally. And here's the important part, everything downstream of that check can now simply trust the invariant. No more defensive null checks scattered through 15 files. No more wondering if this value could theoretically be something weird. The check happened once at the edge loudly, and everything past that point gets to assume the world is sane. That's the actual payoff. It's not really about crashing for its own sake. It's about moving every defensive check to one place right at the door so the interior of your system can stay clean and confident instead of paranoid. Let's look at what this actually looks like in code, because the abstract version undersells how different the experience is. Without fail fast, you fetch a user, the lookup quietly returns nothing, nobody checks, and the code marches on. 3 or 4 lines later, you try to read a property off something that doesn't exist, and now you get a vague error, far from the real cause, possibly in production, possibly at 2 in the morning. With fail fast, the moment you fetch that user, you assert it isn't empty right there with the lookup id baked into the error message. If that assertion fails, you know immediately with full context. If it passes, every single line after that can simply trust the user object is real. Same eventual bug in both versions. The only difference fail fast makes is where the crash happens, and whether you're handed a smoking gun or a cold trail when you go looking for it afterward. None of this means fail fast is always correct, and pretending otherwise is how people misuse it. Fail fast wins when bugs are cheap to catch early, think dev environments or internal tooling where a crash just restarts a test instead of waking someone up. It also wins when wrong data is actively dangerous, financial calculations, medical systems, anywhere bad input is worse than stopping. And it wins at library and API boundaries where invariants must hold for every caller, exactly why compilers and type systems lean so heavily on this philosophy. But fail-safe wins plenty of times too. Public-facing services often care more about uptime than any single request being perfect. Sometimes a default really is fine, a missing optional setting, a cosmetic preference, and sometimes blast radius matters most since one bad request shouldn't take down a server serving thousands of others. The realistic answer blends both, fail fast deep in your code, fail safe at the outer edge. Once you start looking for fail fast, you'll notice it's already everywhere in tools you use daily. Assertions are the most direct version, a single line that crashes the instant and invariant breaks with the broken value right there in the message. Static type systems are fail-fast pushed even earlier. The compiler simply refuses to build the program if the types don't line up, long before anything runs. Schema validation does the same job at API boundaries, rejecting malformed JSON the moment it arrives instead of letting it travel 3 layers deep into your business logic. And circuit breakers apply the same idea to entire services. The moment a downstream dependency starts failing repeatedly, the breaker opens and stops sending traffic immediately instead of queuing up timeouts. Different mechanisms, completely different layers of a system, but the same instinct every time. Surface the failure as close to its source as possible, and don't let it travel any further than necessary. So here's the actual takeaway, stripped down to its core. Fail fast means surfacing a broken assumption the instant it's detected at the boundary with the bad value still sitting in scope, instead of letting it quietly drift downstream until it eventually breaks something else entirely unrelated. 3 things to carry with you. First, validate at the edge wherever untrusted data actually enters your system. Second, throw instead of defaulting because a silent fallback only hides the bug from everyone, including future you. Third, trust everything past that boundary because once a check has passed, the rest of your code gets to stay simple instead of paranoid. A loud crash today with full context and a clear stack trace beats a silent corruption you only discover 6 weeks from now when nobody remembers what the input was supposed to look like in the first place. Thanks for watching.